Hello everybody. This video is going to talk about how to reflect an image across a line using geometric constructions. Now, the big thing here is all reflections end up to where every single point on this triangle ABC is going to be the same distance from this line of reflection as all the points on its image, which will be over here. So that means the closer you are to this line on the top right, the closer to this line you will be on the bottom left, and vice versa. So let's go ahead and talk about a little bit about distance. Now, distance from a point to a line is measured along the perpendicular line. So what we need to do, and I'm going to turn the paper this way just for this bit of construction, is we need to construct three lines perpendicular to this one, passing through each of these vertexes. So we're going to do the method that we discussed in a previous video, where we make our arc, set the labeling of this, and it can be whatever you want it to be. In this case, I'm going to just label it x1 and x2, and then we're going to bisect this just by making a couple of marks on the opposite side from C. Again, when you're bisecting, make sure that you are at least halfway away, and you want to try to make it very clearly halfway away. You can see that you also need to make sure that your arcs are big enough. Okay, so we clearly see that intersection. We bring over our ruler and we go ahead and draw our first perpendicular. And I'm going to exaggerate it again. So we have our first perpendicular. We are going to do that a couple of more times with point A and point B. So we are repeating the process as we did before. Now, you do have to be careful when you are doing multiple constructions this close together, because as you can see, these 2 points are very close, x2 and x1. I'm going to label this intersection so it's clear y1 and this y2. Okay, then we go ahead and bisect segment y1, y2. So I need to be more than half. I do an arc above, centered at y1. I do an arc above, centered at y2. And then go ahead in here and make my line. Okay. And we need to make one more of these. And we're going to repeat that same process. Now B is the furthest away from our original line, so clearly this arc is going to be a little bit bigger. But we're still following the exact same process. I'm going to name this Z1 and this Z2, and now we're going to bisect segment Z1, C2. So make sure we're more than halfway. Just do 2 arcs on the opposite side from point B, centered at Z1 and Z2. And we go ahead and make our line. And the beautiful thing about reflections is they can be used to create all the other transformations, at least the rigid ones. So now we have our triangle ABC, and we have this setup. Now, I'm going to go ahead and label these 3 intersections. I'm going to label them MA, MC, and MB. And I'm doing this so that we can easily identify what these actually are going to be. This is going to be the midpoint of A and its image. This is going to be the midpoint of C and its image. And this is going to be the midpoint of B and its image. So, to get the if that's the midpoint, that means that both sides are the same length, which means that I need to copy this segment here. I'm going to go ahead and label this point. I'm going to label it B prime, which is the notation that's used for the image of B. And we're going to repeat this with C and A. It's useful to point out that when you're doing any type of construction in the geometric sense, it is often easier to work larger than it is to work smaller. So making an arc that's very large is going to be easier than making an arc that's very shallow, and like this one is. But I'm going to go ahead and label that C prime, and now we just need to do this with A. And over here we have the intersection, and that is A prime. So if we connect A prime and C prime, C prime and B prime, and A prime and B prime. What you can see is we end up with a reflected image. So this triangle and this triangle are congruent, which means that this side length is congruent to that side length. This side length is congruent to this side length, and that one are also congruent. So we have 2 congruent triangles here. And this property of reflections occurs because of the relationship between the distances here and here between each set. So from B to B prime is exactly twice the distance from B to M. And that's going to be important when we start looking at this on a coordinate plane. But as for right now, we can go ahead and call this video here. Again, this is just how to do the construction of a reflection. It isn't talking about all the individual aspects of reflections. This is just how to construct it and the relationship between the sides of the figures. That'll do it for this video. I will see you in the next one.